Hi, this is Ms. Hochstetter to explain dimensional analysis. It's currently lunch period, so there's a good chance we might get interrupted in the video, but we'll try and do this smoothly and as quickly as possible, but still make sense. All right, so dimensional analysis is a method for comparing the units of the physical quantities occurring in a problem by using the relationships between the quantities. So this is really ideal for unit conversions. Most unit conversions are pretty like one-step problems, but as we get more advanced in physics, you're going to need to use multiple steps. So this is just a way to keep your work organized so that you get to the right units at the end. So on your purple sheet that I gave you in class, it says how to solve problems with dimensional analysis. So you always start with identifying the given unit, and that is often given in the problem. And that's always going to go in the numerator, and then it's going to be over 1 because that is just the amount that you were given. Then you need to identify the needed unit. So that's what you want your answer to end in, and we just call that the needed unit. And let's see, I'll use green. And the conversion ratio. So the conversion ratio is the relationship between the given unit and the needed unit. So I think it's best to do this by using an example. So it says a person has a height of 2 meters. What is the height in centimeters? So our given unit in this case was in meters, and our needed unit was in centimeters. And our conversion ratio, that's where we need to figure out like what's the relationship between them. So if I have 100 centimeters, we know that there is 1 meter. So how do you know like which one goes on top and vice versa? So we always start with our given right here. So it's 2 meters. And we want meters to cancel. So we're going to put 1 meter in the denominator. So you'll notice here we have meters here and we have meters here. And when we solve this, meters will cancel out with meters, which is excellent. So we know 1 meters, there's 100 centimeters. 100 centimeters goes in the numerator because we want to end our conversion in centimeters. So we want it to end there. Now, this is a really useful tips or hints for these types of conversions. You're always going to multiply the numbers in the numerator and divide the numbers in the denominator. So in this case, it would just be 2 times 100, which gives you 200 centimeters as your final answer. So that's one way to do it. Up here where it says what is dimensional analysis, it gives another example of just using units, in this case yards and feet. For physics, we're only going to be doing meters, meters per second, seconds, kilometers, stuff like that. I'll show you some examples below. So on your practice quiz online, this is the first question for dimensional analysis. It says how many kilometers in 1,234,560 centimeters? Okay, so our given unit is centimeters. Our needed unit is kilometers, and we need a conversion ratio. So this one, it's going to be probably a 2-step one. So our given unit, we always start like this, 2, 3, 4, 5, 6, 0 centimeters. And we need to multiply that by something centimeters because we want the centimeters to cancel out. So centimeters will go in the denominator. So I know that in 1 meter, there are 100 centimeters. And if you don't know how I know that, I'm going to make another video on the metric system, which I have not made yet, but I will upload and then put it in the link at the bottom of this video, so you can just click on that and review that. But we'll just assume that we know that conversion ratio, so 100 centimeters in 1 meter. And then I know that there are 1,000 meters in 1 kilometer. So when I set up this next piece, I'm going to need meters to cancel, so I'm going to put meters in the denominator and kilometers up top. And we know that 1 kilometer is 1,000 meters. So then what you do is you just multiply straight across, and then you divide by each of these. So I'm going to grab a calculator. I mean, you can simply move the decimal over, but I'll grab a calculator. Sorry, I have to go to my desk and get the calculator. So in my calculator, I am putting 1, 2, 3, 4, 5, 6, 0 times 1 times 1 is just going to be the same number. And then I'm going to divide by 100 and then divide by 1,000. And you would get 12.3456. Now, what is the units? Well, I like to cross it out because I find it very satisfying. So centimeters canceled out with centimeters, meters canceled out with meters, and I am left with kilometers. So my final unit is in kilometers, which is exactly what the question was asking in the first place. So that's the answer to number 5 on the practice quiz online. Let's do the next example. This one is much harder. A lot of people missed the second question because not only is it just like a straight length change, it also includes a rate. So it's kilometers per hour and 12 meters per second. So I'm going to switch back to blue. So how many kilometers per hour are in 12 meters per second? So the given unit is meters per second, and the needed unit is kilometers per hour. So ratios that we're going to need. So we know that there are 1,000 meters in 1 kilometer, so we're going to need that. We know that there are 60 seconds in 1 minute. We know that there are 60 minutes in 1 hour. So I think that's all the conversions we'll need to solve this, but we're going to set it up just the same. So I start with my given unit, which is 12 meters per second, and I'm going to put that over 1, times the first conversion ratio. Oh, sorry. For this one, we are going to put meters per second. Second goes in the denominator because it is meters per second. That per means divide. So seconds is actually in the denominator on this, and that's going to become really important as we solve this. Okay, so I guess I'll just start by converting to kilometers first. So in this conversion ratio, I'm just going to be focusing on meters. I'm going to want meters to cancel out, and I'm going to want it to switch to kilometers. So we know, looking at our conversion ratio, that there are, in 1 kilometer, there are 1,000 meters. Okay, so now we did the conversion to kilometers. So now we need to convert seconds into hours. So to do that, I'm going to need my seconds over here. It needs to cancel. So since seconds is in the denominator, I need to put seconds in the numerator. And we know that there are 60 seconds in 1 minute. And then we need to convert minutes into hours. And since minutes is in the denominator here, I need to put it in the numerator up here so that it'll cancel. So I get minutes and then hours. So in 1 hour, there's 60 minutes. So in this one, we're going to multiply all the numbers in the numerator. So in my calculator, I am going to put 12 times 1 times 60 times 60. And then I'm going to divide that by each of these numbers in the denominator. So divided by 1,000, and then 1 and 1. And when we do that, we get 43.2. Okay, but what are the units? So we know that we want the units in kilometers per hour, but let's see if we set it up correctly. So meters cancels out with meters, and we're left with kilometers in the top. Seconds cancels out with seconds. Minutes cancel out with minutes, so we're left with kilometers in the numerator divided by hours in the denominator. So that is our answer, and that is the correct answer, and that is how we do these problems. All right, if you have any questions, you can, come see me in office hours. Also, make sure to subscribe to the channel so that you can get all the updated videos. All right, that's all.